Okay, so hello everybody. This is Joshua Harrell, and I'm going to go ahead and I'm going to wait on one participant real fast, and then we will go ahead and get started. So, went ahead and sent him the link, and I'm just waiting for him to get up on here. So, that's that. Here we are. Hello, and there's our first viewer. Alrighty. So to start this off, what is quantum teleportation? A lot of people ask me. A lot of people don't understand what quantum teleportation is, or they just don't understand how it works. So, in simple layman's terms, you can say pretty much quantum teleportation just involves two different distant particles, okay, which pretty much are entangled, okay, in which the state of the third particle, which will come into state, instantaneously teleports to its state to the two entangled particles that were seen. A lot of people don't know that last year, actually, scientists have confirmed the information could actually be passed between photons on a computer chip, even when the photons were not physically linked. So that actually tells us that data can already be sent quantumly. We can teleport data, okay, without needing a cord or without needing any, wireless communication, transceiver receivers or anything like that. So no transmission needed. Um, and a lot of people don't know what this is known as, but this is known as quantum traversal. So it pretty much requires a quantum link or a quantum entanglement. Now, a lot of people don't know that everything is linked. Everything is quantumly entangled technically because we all come from the same source, what most people consider known as the Big Bang. So if this is true, then this means that technically scientists like Einstein and other scientists before him, and even after, Nikola Tesla before him, Stephen Hawking afterward, and many others, had actually come to the same conclusion that there are multiple dimensions, there are multiple realities, and that if we do understand teleportation, we can definitely and 100% most likely will accidentally stumble upon them. So how do we do this? A lot of people ask. A lot of people ask, is there a device we could make, maybe, that people don't want us to know about? Well, yes, there is, and it's actually been proposed a few times throughout history. However, it's never been perfected, so the design has had flaws. Okay, and I believe that today we're going to fix those flaws. So stay tuned, because we're going to go ahead and get into cymatic matter teleportation shuttles. Okay, so let me go ahead and bring up my notes, and we'll get right into it. So, cymatic matter teleportation, temporal gravity distortion, space-time modulation units. You compare them with hyperdimensional resonations units and also dispersal and emission units, coupled with megawaves, which use 4 Chladni plates with high voltage electromagnets and Faraday cages behind them. This is allowing for each to cast an electromagnetic wave in a 180-degree angle of approach, okay, with a frequency vector change distance of approximately 45 quantum nanometers per second squared. So, thus meaning pretty much it shall cast a perfect 4 beams of electrified sound waves toward the desired specific point of direction within space-time. Pretty much, it'll look like how the Death Star takes all of its beams and it points them into one. Very, very similar. So in this case, it will have to be directed at something very specific and able to withstand such energy, though. Because as you can see with, Death Star tech and stuff, well, it hits the planet and it cannot withstand it. It just goes, poof. Well, that'd be kind of like the same, result that we'd get on a small scale if we were to sit here and hit it with just any other normal material. So we have to get something that can withstand such heat. So not only do we need something that can withstand it, though, we also want something that can harness it and maybe even use it for transportational purposes. So in this case, instead of just using like a neutronium rock or something to harness and hold the energy, or a crystal to absorb it, instead, what if we used something like a neutronium metal inner core space shuttle? So what if we actually made the whole entire inner core out of that material to where it could refract and hold such light, to where it's allowing it to escape, but so slowly that it almost looks like it's just glowing. Okay, if we could do this, then the possibilities are endless. We're talking about a space shuttle with a superheat resistant outer core on all sides, zero windows. You'd have to use some type of viewing source like little cameras and then monitors on the inside to act like windows. Um, you'll also have to place a shuttle within a Faraday cage. This is to pretty much make sure that all the people on board and inside don't get electrified and fried. So that's that. You're also going to have your cladding design, and you're going to have it within the actual shuttle. So you can then pump the cage with a specific gas known as xenon. This is actually the brightest and hottest gas that you can actually burn, other than argon, that I know of at least. Uh, you can then continue to evacuate all the air in the inner frame. Okay, this isn't the air that's being breathed in by the passengers. This is the air in between the two sections of the hull. Okay, and you can pretty much evacuate all the air with a vacuum pump and simulate the conditions of the push and pull of the vacuum of space. If you do so, you can then start to pump krypton gas within this into the discharge chamber and start to ionize it by feeding a triode directly to the outer hull of this shuttle. Doing so pretty much allows you to cause St. Elmo's fire. Okay, St. Elmo's fire is pretty much a high field of high energy plasma that envelops the craft. A lot of people actually know St. Elmo's fire as, I guess you could call it a force field, a plasma force field. So look up St. Elmo's fire if you don't know of it already. It's very, very, very interesting, and I've actually seen it occur a few times. So just if you haven't seen that yet, definitely go ahead and look into St. Elmo's fire. So St. Elmo's fire will pretty much occur and envelop the shuttle in a high field of plasma. Then using a high electromagnetic field caused by 5 magnetrons containing beryllium oxide, aluminum oxide, and chromium oxide, and 5 neutron guns containing americium isotope rings and thorium rings under it to act as an extra clean fuel source and a boost. Okay, all while being fully and safely stabilized by 4 rapid start mechanical ballasts. Then we have a door on the unit, which, like typical modern microwave ovens, acts as the bridge connection to complete the current, which allows the startup of the unit to initiate only when the door is closed. So, pretty much only when the current's bridge is complete can the unit operate, of course, just like any unit, really. As it operates, the next thing to do is to start the quantum rosin link. And this is where it really gets interesting. This is where the entanglement starts. So the rosin link, or the quantum rosin link, or QRL, as I'm calling it, is where we use a specific pure cymatic frequency ladder to find and match the frequency of the craft and its dimensions. And once we do this, we can start priming the shuttle for transmission. And then we will use a high-energy laser array system to concentrate and bend the electromagnetic waves along with the gravitron in the specific point of interest, thus allowing us to bend light and therefore space. And in doing so, we can even bend what is perceived of as time. So this is the most crucial process of it all, and the most dangerous. This is also the transitional process. We're going to need a very special type of calculator compass for this transitional process, one that works off of a 3D cartographical data as well as 3D astrospatial chronographical data. It's also going to be needed to be paired with a quantum compass. And if you don't know what that is, it's pretty much an instrument which measures relative position using the technique of atom interferometry, which includes an ensemble of accelerometers, gyroscopes based on quantum technology to form an inertial navigation unit. The work around quantum technology-based inertial measurement units, or IMUs, is that the instrument containing the gyroscopes and accelerometers follow from the early demonstrations of matter wave-based accelerometers and gyrometers. The first demonstration of onboard acceleration measurement was made on an Airbus A300, believe it or not, okay? And in 2011, using a quantum compass containing a cloud of atoms frozen using lasers and lasers only, okay, that were cooled to below 0 temperatures, all right, by measuring the movement of these frozen particles over precise periods of time, the motion of the device can then be calculated without having to be there, also known as a quantum compass, okay? The device would then provide a tamper-proof, accurate position in circumstances where satellites are not available for satellite navigation or where they simply cannot obtain nominal telemetry data. Nominal being pretty much your default or your normal, okay? Various defense agencies worldwide, such as DARPA or even the United Kingdom Ministry of Defense, have pushed the development of prototypes for future uses in submarines and aircraft using this exact same technology. A lot of people don't know that. So why shouldn't we use it for multidimensional travel, I ask? And if you guys agree with me, please leave a good old reply there in the comment section, because that's exactly what I'm thinking. I'm thinking we need to use this technology for things that it's actually going to be viable for, that we're going to need in the future, not military warfare and crap we don't really need. I mean, it's just causing mayhem. You know, if we went to a different dimension, military warfare may not even exist. In my opinion, I see that as a way bigger one-up than using it for a submarine. So it's just my honest opinion. A lot of people don't know how to make this work. You're going to have to use an inverted Mobius strip. Okay, we should be able to harness the tachyons within the chamber produced from the plasma ionizing, and we can slow and speed them and then merge those remaining into the predestination transition sequence, allowing for precise time-dilated temporal relocation. Pretty much tactical or practical space-time travel, as it's more commonly referred to. This would pretty much look something like a cymatic teleportation shuttle device. I actually have on my notes here a digital wireframe of the prototype. So if you want to go ahead and look at this, I know my phone's all completely broken to crap, but that's actually what it would look like. That's a wireframe of the design. And these are the Chladni plates on each side. Okay. These are the Faraday cages. So, and then you can see the coils behind, and you can also see the speakers, which are directing the sound waves. So, very, very interesting. And then there's prototype 1. Let me see if I can give you guys a good view of that. It's really, really hard to see here. It's not really that good. too much reflection, I'm thinking. And then there's a prototype 2 in action. That's a little easier to see, but it's also got a lot of distortion in it. And as you can see, that is a perfect St. Elmo's fire. Perfect field of plasma around the desired shuttle. So, and then here's a larger wireframe of a different mock-up we're trying to actually design. And we believe that the other advanced research agencies have already designed one, due to the fact that we have this, which looks very similar to such design. So I don't know how well y'all can see the similarities, but we believe this to be the overall version. So overall, it will pretty much take you from one place to another, with the Mobius strip intact and with the other units intact. So only when all units are working in unison does it all work. That's what a lot of people don't understand. So people have used space-time modulators and they've used hyperdimensional resonators and stuff like that, but they can't get them to work. And that's because they don't know what they're doing. They simply don't understand quantum mechanics, and they simply don't understand the science of quantum teleportation whatsoever, or quantum relocation, or temporal relocation, or any of that. They don't understand it. And that's the biggest problem with today, is that all these people are putting all this money into things they don't understand. And if you want to get somewhere, First, you have to simply understand it. So let's keep going with the shuttle, and we'll go ahead and we'll get into some more things about how it works and what it can do. So go ahead and get this back here. Here we are. Here we are. Okay. So it pretty much works due to the fact that two things cannot exist at the same given moment within the same given time and place, or at least two particles cannot, which, well, everything's made of particles, which are made of atoms, and everything's got atoms in them. So, yeah. Pretty much, if they do, they either cease to exist at all, or they cease to exist within that place. The only way to be truly non-existent is to bombard the same exact atoms to nothing else by fusion. This means that if two particles within the same given makeup are at the same exact place, the same given time, and they have the exact same given makeup within them, then therefore fusion has no other choice but to take place and occur, destroying either one or both of the same given particles. By combining both energies into one, only of those particles and allowing them to either exist or coexist allows for fusion or not fusion. So to make two particles one, we need Farnsworth-Hurst fusers. And to do so, then we're going to need high energy gamma waves to be passed through them with the same given frequency as the given wavelengths, and that the same given time and space, thus directing all the energy into one exact subatomic point within space-time itself. Therefore, space is time and time is space. So we just made two into one. So the only way to ensure this is to allow gravity to push and pull particles into the same place, much like the intense gravity of a black hole. So in theory, you'll be creating a black hole by doing nothing more than supercompressing two particles to one and passing two identical ions throughout the exact same space within time. So this would cause the ability and effect similar to distorting magnetic fields, but instead we are using highly intense gravitational pull that distorts space-time itself. So it's a little bit different. As we know, there are highly intense gravitational pull fields around black holes and also around white holes and stars, and also very large objects. It's going to be the exact same thing. It is technically slowly but surely, in a very small way, bending space-time. And this is pretty much how these dimensions of the space-time travel works. It has an extra dimension. So we have, certain dimensions as space. Okay. I guess you could actually say it should be different. I guess you could say we have 3 dimensions, right? But if we had 4, it would make more sense. I guess that's an easier way to say it. Say if we had a 4th dimension, okay, we'll call it time. Okay. Let's say we have a meeting and we need 3 points of dimension to be able to reach it. Okay, without the 4th, without time yet. Okay, this would be 2 points of direction and 1 point of depth and point A is north and south. 34th Street runs north and south in New York, so we'll use 34th Street as our point A. Okay, point B, east and west. Okay, or left and right. Let's see, 17th Avenue runs east and west in New York, so we'll use that as point C. 17th Avenue is point C. So point A, 34th Street, 17th Avenue, point C. All right. Now, we're going to need, point B. Now, we're also going to need an extra point, or our third point, point C. That's going to be our depth and our height, okay? And that's going to be our 51st floor, upstairs or downstairs. Either of the two represent and depth or height. It really didn't matter which one you want to call it, because it could represent down or up. However, this isn't enough to really reach the meeting, as you may have thought, because there are also a specific time in which the meeting will take place. So we now introduce a 4th theoretical dimension, and we're going to call it time. Point D is time, 9:56 a.m. or p.m., either one. Now, this is the reason. Think of it. Just really think of this. If time isn't a dimension, then how the hell are you getting to your meeting? Okay, think of it. Okay, look, I have a meeting at point A, point B, and point C. Okay, north and south runs, like I said, 34th Street on New York will run north and south. Okay, point B, 17th Avenue. All right, so I'm going to be going in 34th Street and 17th Avenue, but I still don't know exactly where in that building I need to go. So I need to go to the 51st floor. That's point C. That's my 3 points of dimension. All right, frontward, left, right, and up or down. All right, I got my 3 points of dimension. I have my coordinates. I've got the place I need to go. All right, that's my dial-in. However, if I just go there any given fucking time, it's not gonna work, right? Because that meeting is gonna take place at a certain given time. So if I just put in those 3 given moments, what if I get there and it's fucking nighttime? Nobody's there. So to actually figure out time travel, okay, because teleportation is nothing. Okay, time travel, you have to understand that time is a dimension. It is the 4th dimension. So we're not just going to go to 34th Street, 17th Avenue on the 51st floor. We're going to go there at 9:56 a.m. or p.m. or whatever, whatever the actual time is. So you have to dial that in. So we need that quantum calculator and we need that quantum compass to be able to determine where the hell that is. So if that makes it simpler, that's how time and space are manipulated. That's how it would be done. You'd have to see time as a dimension. So, that's really the only way you can do it. So pretty much, and I've got some more notes here I got to go over. You could reach your meeting at the exact same time it actually takes place. Otherwise, you'd just be standing in an empty conference room, of course, like we explained earlier. Anyway, you pretty much just experience the space-time transportation in doing so. Now, all we got to do is speed that up a lot. And we need to do it in such a way that you're not physically actually moving. So to do so, you have to bend space around you. Okay, this is known as temporal relocation. Some people also call it temporal displacement. It really depends on what you want to call it. Doesn't really matter. There's been all different kinds of before mentioned names for it, but it really, like I said, none of it really matters as well as you understand the concept. So there is a way to experience real-time travel. The ones that you experience, like that you'd probably see in movies and sci-fi and all that. And it's a little different. Like I said, temporal displacement, temporal relocation is the act of traveling through time without affecting space, as if it were a medium. Okay, as if it were an actual media. All right, so to do this, you'll have to travel at the rate in which all lasers and other forms of visible light travel. However, humans can never travel at the exact speed of light, only above or under. But what says that there isn't another unknown form of light, in which we just haven't found yet, that actually travels under the before-mentioned speed of light? This would allow us to observe it, understand it, and thus finally harness it. Doing so, we can use it to travel space and time while only affecting the time itself within that given space and not the space around it. So if that makes sense, pretty much, I guess you could say it's pretty much the only way without affecting the space-time continuum as it currently stands before us, or pretty much the only way to stop from, like, I guess you could call it paradoxes. Is that what they're calling it nowadays? Paradoxes. So, yeah, if you don't want paradoxes to occur, then that's just that. You're going to have that implemented into the system, or else you're going to screw things up and it's going to be really dangerous. I mean, either way, all this is really dangerous. And I don't think anybody's ever really delved into it like this. But John Teeter, he's actually somebody who spoke on this just, I guess you could say, in a small amount, because he really didn't understand it as much as a lot of people think he did. But he really was just speaking about something he saw and something that he experienced and something that he had worked with. And what a lot of people don't understand is he's experiencing and working with these exact same things. And I mean, exactly. All I'm doing is scientific representation on it. And all I'm doing is making it more factual, because he wasn't lying and he had no reason to lie. just like Robert Lazar and other people in the past, they had no reason to do something stupid like that. So now that we have the uh, pretty much now that we have the way of affecting, way of not affecting the space-time continuum as it currently stands, uh, we pretty much now have to travel to an exact given moment. So we will need the exact given location, and this means that the location, or also known as the dimensional space, has to do with the moment in which we travel to or time in which we must rely on. So we're going to have to rely on gravitational waves for push and pull to achieve this correctly. This means that space is time and space-time is gravity bound. Therefore, without gravity, time and space act and react quite differently than what we would expect on Earth. And since it takes some form of action or energy to be exerted and able to travel at all, this means that time, space, energy, and gravity are all linked. So, pretty much, if you calculated them correctly, they could be bent, manipulated, changed, and even broken, therefore allowing modification to the laws of physics themselves. And this is really how quantum physics plays its part, because quantum physics does not abide by the same laws as relative physics. And in 2034, supposedly, as uh, some have speculated in certain secret communities, which have said that they've actually worked with these machines, and that they've been to future realities. They said that they have a machine known as the C204 Quantum Gravity Distortion Time Displacement Unit, or QGDTDU, okay, or commonly referred to as just the time teleportation machine, or just time machine. It works on an exact same principle as I have given above, and this is what John Titor has used in 2036 to travel back into 1994 to change the all-known death of Nelson Mandela and start what we now know as Mandela effects. A lot of people don't know that. This is in turn what we call as a fly paradox, in which John within his future would never have traveled to 1994, but instead traveled to 2001, and that John himself suddenly disappeared into a burst of light, and only to reappear from the year 1994 to 2001. This is when he made it again very evident that time travel was possible, very physical, and not only at all easy, but was as well very dangerous due to the complications that could arise within it, and did. And even weirder than that, what is said is that the only reason General Electric developed the time machine within, known as from the stories of John Titor, is because John Titor actually told them how it works. Pretty much what I'm getting at is him coming back in time and telling them how it works is the only reason it was even built in the future in the first place. So it's a paradox. Okay, it's a fucking paradox. It's a non-stop, ever-going loop. John Titor is stuck in the same day, and so is General Electric. This is why we have to see General Electric shut down. So, there's things that we look at today that are really just mysterious. The rabbit holes that nobody can get to the bottom of. But I seem to have gotten to the bottom of them, and it's like it's too easy, and it's scary, but it's cool and it's interesting, and I think that other people can really learn a lot from this. And to go into our current reality that we live in, pretty much his design, okay, the future and the past are already set in stone, because without the future, we pretty much can't have the present. Without the present, we cannot have the past. Therefore, the past, present, and future are not three, but all the same, pretty much. They're all the same thing. A lot of people don't know that. And this may be getting very confusing. However, it takes a very inclined intellectual brain and way of thought to understand the possibilities of quantum physics in itself as it stands today. However, but one does not have to simply understand to act. They just have to be willing to commit the act itself. So, it's not that you have to understand how to travel. You have to be willing to do it. That's the biggest thing, because it's dangerous. It's really dangerous. And in the future, a lot of people aren't going to understand it when it is publicly accessible and when it is commercialized. It's just going to be something people do. You don't understand how an airliner works, but you go in planes. You don't understand how a train refuels every 5 minutes, but you do it. You go on the train. People just, when they see something and everyone else says, oh, it's all fine, then that's just what they automatically think. They don't have a second guess about it, and that's the biggest thing is, With time travel, it's going to be a little different. I do think that people won't really understand it and that they won't really care that much, but I also think they're going to be hesitant at first because it's going to be a new type of transportation and it's going to be completely radically different from any other form we've ever seen before it. So just to see that itself is kind of insane. But pretty much a good example of this whole event, though, throughout Hollywood, though, is the Days of Future Past. If you haven't seen that movie, it's a really, really good movie. I think they've actually changed the movie's name for some reason. If I'm not mistaken, recently they've changed the names. So, if I'm not mistaken, Days of Future Past. Yeah. Yeah, no, they didn't change the name. I can't fucking remember the name. Anyway, not the point. Anyway, what if I said that the only reason you were even sitting where you're at right now is because in 10 years you meet a future version of yourself from 30 years ahead of you, okay, at the given time, which tells you that you need to go back in time to the before that your present is in now in order to make sure you're sitting in that exact place at that moment of now. Scary, right? I mean, it's weird. Like, what if, okay, think of it like this. What if right now, okay, I went into the future. All right. If I'm in the future and this already happened, that means I'm still technically here because it has to be happening. So you can't technically, like, when you're going into teleportation, you're technically copying yourself. And another really good example of this actually is The Fly, a really good movie. Now it has nothing to do really with, I mean, it does, but it doesn't. It doesn't really have to do with teleportation per se. I mean, it does, but it really has to do with like monstrosities and becoming a grotesque monster. But it's not the point. If you've ever seen the movie, you'll notice a scene in which he shows pretty much how you're pretty much copying, you're duplicating your subject. And in some cases, the computer does not know how to duplicate certain things like cellular structures like skin because it duplicates it to where it looks real, but it doesn't feel real. It makes it of different materials. And see, this is a big problem. If you're going to duplicate yourself and then send your genetic genome structure and your neurological structure, your thoughts over, then destroying yourself in the process would not be fun because it wouldn't work. Because what if you transferred into like a robotic body or a non-human body? You know what I mean? That's really one of the only ways to do it so far. So unless we have printers or some type of way to make bioorganic material which lives and breathes just like us, we're not going to be able to really pull off this technology. However, they do have prototypes within the field that can do this. They have not come out commercially yet. So we're looking at another 10 to 20 years. These are known as 4D rapid prototypers. Okay. In the movie Jurassic Park 3, actually, they use a 4D rapid prototype, okay, that wasn't actually finished yet, and they use it to actually build a quick skull on set. And they showed it in a scene. They used it to simulate like they blew through it to simulate the effects of a velociraptor's vocal cords and what it would sound like. And that little bone structure they were blowing on, it was made out of a rapid prototyper, which had made that thing in 5 minutes. Normally, that'd take a sculptor hours and hours and hours to make that same little thing. So it's like a printer, but it can print the insides and outs of an object. And it being not 3D but 4D allows it to print moving parts and also get into the aspect of how long should a part work? How long should it last? Things like that. And that's something that I think is really, really important for, teleportation in general. So anyway, 35 minutes is coming up pretty near here. So I'm going to be cutting a little short, you guys. But I hope you guys did enjoy this segment, and I hope you guys understood a lot of the stuff that I went through. If you did not, always you can go back. You can always message me, and I can send you links. I can send you really any referencing you need, honestly, to what I'm talking about, to where you guys can honestly get more of a practical understanding or a basic understanding on the information that was given in this video. So, there are ways, though, 100%. There is going to be teleportation. Okay, it is coming, but it's just a matter of somebody doing it. So it's a matter of when. Anyway, guys, peace out.